will discuss about elements of pulse code modulation. Pulse code modulation is used to convert analog signal into digital signal. I am assuming, for example, so this is the image or audio signal we can also take. I am taking just for assumption. This image is converted into, that is, analog signal. This is the analog signal after conversion from physical to EM wave, electromagnetic wave. So we can transmit for long distance communication after modulation, either amplitude modulation or phase modulation or frequency modulation for long distance communication. But because of advantage of digital communication, we are going for that is digital communication, digital transmission. So this signal, analog signal, need to convert it into in the form of digital. So by using sampling and quantization, we are converted this image or this audio signal or this video signal can convert it into digital form. So then we can transmit. The advantages you have seen in the last class. So here you can see this advantages of digital communication system. Noise is very less and secure transmission, and interference also very less. So that's the reason, and the complexity is very easy, very less in digital communication. To design, to transmit the signal, so it is very easy. That's the reason we are going for digital communication. So here you can see this, the elements, this is the procedure for PCM, that is elements in PCM system. So for example, the same image I am taking here, the transmitter is there and receiver is there. Just assume this. This is the image I need to transmit using digital communication. So first it is converted into, that is EM wave, electromagnetic wave. So this image, you can observe this left side corner. So here you can see this left side corner. So this is the equivalent EM wave, electromagnetic wave. So source of continuous time message signal. This is the analog signal. The image is, physical signal is converted into continuous, that is message signal. This is the signal. And as you know that low pass filter, left side corner you can see this low pass filter. So the low pass filter function is just it will allow only low frequency and stop other unwanted signals. Then so here this is the sampling techniques. This signal, message signal is converted into, that is, this is after low pass filter transmission. This, just assume this is the signal, our image, and this is the sampling. Sampling is used to convert, that is, normal signal into samples. This is the sampling signal, just assume. But here also again the sampling rate should be twice of the message signal frequency. Fs is greater than 2 FM. This is the sampling process. I will tell you anyhow. This is the sampling rate should be. Here you can see this. The sampling rate should be equal or greater than or equal to 2 FM. So then only we can get the exact signal without any distortion. If it is less than 2 FM, you may get the distorted output. That is the reason the sampling rate should be, this is the image, just assumption. The image is converted into, that is EM wave, electromagnetic wave, and while sampling, this sample should be greater than 2 FM. This is the message signal, for example. This sample frequency should be greater than 2 FM. twice of the message signal. Then only we can, while reconstructing at the receiver, you will get the exact signal. If you are sampled like this, you can see this. We can't expect where is the signal. You can assume like this. Sometimes you can assume like this. You can assume like this. So that's the reason this sampling rate should be, that is 2 FM. That is the reason. Then only we can reconstruct easily while decoding the signal. So that is the advantage for the Nyquist rate. So what he is saying that sampling rate should be double of the message signal frequency. Then only we can get. If it is more, that is okay. That is better to get. Why are going for sampling to convert analog signal into digital? So that is the Nyquist rate frequency. So anyhow, so here you can see this. As I said, this is the sampling. So analog signal is converted into samples, and this, of course, again the sampling, different types of samplings are there again here. Flat top sampling is there, natural sampling is there. That is the one more topic. So these sampling levels are quantized. So that is coding. We are giving coding for that. That is, each sample is having equivalent binary code. Each sample is having infinite number of samples uh, or predefined, assigned some coding. That is the quantizations. That is the quantization. Here I can, I'll tell you here. So here, so the same thing. So quantization will at the quantization. So here this original sample value is converted into, that is digital, that is encoding value. So this encoding will gives the, that is digital PCM signal output. For example, here this is the sample, as I said, this is the image is converted into analog signal, and this analog signal is passed through low pass filter. In low pass filter we'll get the required low frequency only, and this analog signal is again converted into samples. This is the samples. Sampling rate is there, so it should be compulsory, should be converted into required sampling rate. Then only we can reconstruct easily while decoding the signal. So quantization will gives the quantized values, and that quantized value, each quantization value will have, that is separate coding. For example, this quantizing value 101, and this is the quantized value, that is 110, like this. Finally we can get, that is 101, 110, like this. This is the equivalent digital code. Initially it is an image, just assume, or video signal or audio signal. So after analog conversion from EM wave, this is an analog signal. Again analog signal is converted into sampling. Samplings are converted into coding, encoding, quantized values, that is called as, that is encode. We are assigned finally encoding, that is digital signal. We are converted. So again that is named as, that is pulse coded modulated signal. So here this is the signal. Then here you can say this distorted PCM signal produced at the channel output. Regenerative repeater. The regenerative repeater function is, it will again regenerate. It will reduce the noise and it will stop the noise, and again it will regenerate the, if the signal strength is less, it will regenerate the repeat signals. So here again the second stage regenerative repeater is there. So this is the at the transmission path this will happen. So at the receiver end you can see this, again we will regenerate the signal, and here again This decoder function, as we know that it will converted into, that is original signal what you are transmitted. Again, these samples or reconstruction filter will convert it into what you are sent. And here after this, at the destination, again this analog signal is converted into our original physical form, either video signal or audio signal or any other information. So this is the process will going on in PCM, pulse code modulation system. So initially we are transmitted, that is just assumption, one image converted into analog, and analog signal is filtered again, our required frequency only allowed, and this filtered signal will convert it into samples, and samples are quantized, given samples are converted into quantized values, means predefined coding, and finally we are encoded a signal, that is the transmission side end. And at the receiver again we need to convert it into our original signal, and we need to reconstruct the filter, that is called as decoder or demodulation process. This will happen in PCM, pulse code modulation system. Thank you. If you have a doubt or suggestions, send to me.